Welcome to AutoSens, the world's leading community for ADAS and autonomous vehicle technology development. We create best-in-class events, training, and information for the purpose of connecting the global community of engineers, scientists, and other automotive industry experts. Today, we are joined by Rubén Pérez-Aranda, CTO and co-founder at KDPOF. And Rubén, welcome to AutoSens. Thank you for being with us.
Hi, good morning. Welcome.
Rubén, the value proposition of optical links versus electrical links. Let's start here. The value proposition for optical links versus electrical links for sensor connectivity and car networks in general. What are your thoughts there?
Yeah, thank you for the question. I think it's a very important one. The main value proposition of optical links in automotive is the EMC performance, electromagnetic compatibility performance, the power consumption, and it's a future-proven data rate cable technology. Today, the electrical cables, the balanced ones or coax cables, show very high insertion loss at high frequencies. So, for example, the cables used for camera connectivity have about 40 dBs at 10 GHz in very short cables. And so these together with return loss problems translating into signal integrity and EMC problems. So you need to have high complexity DSPs in the integrated circuits in order to compensate these problems. And these problems are even worse with the aging of the cables caused by thermal and mechanical cycles. For example, imagine a camera that is in the trunk door of the car, and you are moving the trunk door, so the cables suffer a lot, or in the mirrors. However, the bend-insensitive multimode fiber OM3 that was chosen for automotive optical multi-gigabit applications support 3 dB bandwidths of more than 20 GHz at 40 meters. It's a dielectric medium, so no electromagnetic immunity and emission problems. And its optical fiber solution is not only for cars, but also for trucks and buses.
The multi-gigabit optical links, they're highly deployed in data centers and in telecom. But there's a new optical physical layer standard for automotive, and that was released just in March of 2023. Rubén, can you take us through that standard and then tell us why that standard was developed?
Yeah, that was a new project in IEEE 803 working group. During the study group phase, that is the first phase before starting the standardization project, we needed to be very focused on technical feasibility and economic feasibility. And it was demonstrated during this phase that a new optical PHY standard, different from the datacom, was needed for automotive because the requirements are very different.
So we have this new standard. We have a good picture now of the optical links versus the electrical links. With that in mind, Rubén, what are the differentiating aspects between this new standard for automotive, maybe compared to the ones that are used currently in data centers?
Yeah, right. Datacom PHYs are designed assuming implementations are going to operate in a narrow range of temperature. However, in automotive, you require to support operation between -40 and 125 Celsius degree in junction temperature in the integrated circuit. And the temperature affects a lot the operation of the photonics and electronics. So you need to consider during the PHY design and the standardization development these conditions. The datacom PHYs are designed considering that you have a small attenuation in the connectors. And the performance is limited by the bandwidth and noise limitations in the transmitter and the fiber itself. However, in automotive PHY, you need to support much larger attenuations caused by vibrations, dust, and these conditions that are specific of the automotive. And you need to provide solutions of this connectivity with very limited cost. So it's a tough task. And we solve this problem with a good design of the PHY, of the physical layer. Also, the quality requirements are very different. For example, the technology nodes that you can use in the foundries are limited to CMOS for automotive applications. And in Datacom, you are free to use SiGe BiCMOS technologies with higher gain bandwidth products. So you are limited in the technology nodes that you can use with the right quality service in the foundries. And the reliability constraints are very different. For example, we needed to change the wavelength, the light wavelength that typically used in multi-mode communications in data centers, that is 850 nanometers. We needed to change to 980 nanometers in order to have photonics with much superior reliability. So the application shaped a lot the design of the physical layer and the standardization.
Yeah, that's so well said and very interesting. Speaking with Rubén Pérez-Aranda, CTO and co-founder at KDPOF, a complete optical link solution, Ruben, it would need many different components from, say, photonics to connectors to cables and so on. Which components and technologies then can be leveraged or can be prioritized? Ultimately, which ones need to be developed then specifically for automotive applications?
Yeah. There are several components that can be leveraged. For example, the band-insensitive multimode fiber is leveraged. It's a very mature technology with decades of experience. So it's a very good choice to select this fiber. We have a lot of providers around the world with very high quality. Other components that can be leveraged is the PIN diodes used in infrared communications, also very mature technology. And for the lasers, for the vertical cavity surface emitting lasers that are used in this application, what we call pixels, we changed the wavelength, but we are leveraging technology and experience of the last decades in data centers because it's the same design principle. And we are using long wavelength, but we are leveraging the experience that many companies have using these pixels for high power applications like material processing. Regarding to the connectors, cables, and so on, we need new designs because the environmental conditions are very different and the mechanical requirements are very different in automotive. So new connector and cables need to be designed as well as transceivers because you know that in data centers typically is used these SFP modules that can be connected and disconnected in the routers and the switches, but this is not a valid solution for automotive. In the automotive, it is expected that you provide a fully integrated chip with the capability of being assembled in the PCB with a standard reflow process, a standard pick and place process, etc. So new transceivers need to be developed for this application.
You know, Ruben, with everything we've been talking about here, and I've so enjoyed this conversation. It's been fascinating and really eye-opening. But I suppose the big question now is now the time for multi-gigabit optical networks in cars? Is this the right time to be pursuing this?
Yes, I think so. I think so because the need is there. We have high speed and low latency use cases, sensor connectivity, aggregation in zonal architectures, everything, all the sensor information connected to the artificial intelligent brains to make the sensor fusion. So the need is there, and the copper is approaching the limit in speed and EMC performance. It doesn't not scale for the future. It's not a future-proven solution, in my opinion, when the data rate or increase with more and more information that needs to be provided to the computers installed in the car. And the full ecosystem involved in the optical solution is under development. So we have international standards like the one that you mentioned in IEEE 803. We have the development of photonics by several companies. Transceivers, we are doing the transceiver, cables, connector, and test and measurement equipment. So you have all the pieces that are needed to develop to have a complete ecosystem to provide a solution to the automotive market. So yes, I think so is the moment for multi-gig optical networks in cars.
Yeah, and like I was saying a second ago, it's so fascinating to hear your perspective on this, and then looking at the difference between, automotive applications versus the design centers. And Rubén, fantastic, fantastic. We've been speaking with Rubén Pérez-Aranda, CTO and co-founder at KDPOF. Want to encourage all of our AutoSense viewers and AutoSense attendees to visit the KDPOF website to learn more about everything we have been discussing. Rubén, in the meantime, thank you for being with us. Thank you for sharing your expertise and thought leadership. Look forward to being able to doing this again, hopefully sooner than later.
Thank you.
For more in-depth interviews like this, subscribe to our YouTube channel and follow AutoSense on LinkedIn. For more information on our world-class events, visit auto-sense.com. That's auto-sense.com. In Detroit, on behalf of AutoSense, I'm Carl Anthony.